Question 20 is one of the most difficult questions in locus, coordinate geometry. And then they say that there is an obtuse angle. So obtuse angle, that means one of the angle is larger than 90 degree, OPQ. And then denotes the in center. In center, that means there is an inscribed circle inside. And some property which is related is about tangent from external point. And then the in center is called I. And at the same time, there is the circumcenter, which means that the triangle is an inscribed triangle of a circle, and the circumcenter is J. The property related to circumcenter is the perpendicular bisector of all the length, of all the sides of this triangle. So, and then we have to prove that one more thing is about P. Point P. So most probably we are talking about this point. Point P, point I, and point J are collinear. In this graph, it's not collinear. So this gives some information that they are collinear later. We are going to modify our graph later. But in the first trial, we think that the graph should be like this, and then we can modify it by using this information later. Before that, just like what I mentioned, this is angle bisector because it is the in center I. So angle OPI and angle QPI are the same, they are symmetric. Second thing is about the circumcenter. Circumcenter is the perpendicular bisector of the side. And one more thing is about the in center. I to this edge, this is the radius. Radius and the tangent are perpendicular. So we know that they are perpendicular. So if we update the story, if we assume this is point E and this is point E2, collinear, which means that E1 and E2, in fact, they are connected to each other. To make this possible, which means that OPQ should be isosceles, which is consistent with the conclusion here. Collinear, which means that they intercept OQ at point E. It's not 1 and 2, but they are one single point. This is perpendicular, this is perpendicular also. To prove it is isosceles, or we say it's symmetric along this line, then we may look at the triangle here. It's because of radius perpendicular to tangent. We have 90 degree. We have a common side. And don't forget the meaning. The definition of circumcenter make this become a midpoint, perpendicular bisector of OQ. So we have sine, angle, sine. We can use congruent triangle to prove triangle POE congruent to triangle PQE. Thus, we can use corresponding length, corresponding side to prove that this is isosceles. Because they ask us to use to prove this word, that means reason, reference must be provided. And you see, quite trouble, but you still have to write. First, denotes the intercept point of PJ and OQ be point E, so that we can say angle PEO is equal to angle PEQ equal to 90 degree. The reason is radius, perpendicular tangent. Second, PE equal to PE because they are common. Lastly, OE is equal to EQ. That is because circumcenter of triangle. Because of 3 pairs of information, we can say that therefore triangle POE congruent to triangle PQE. The reason is sine angle, sine, SAS. Therefore, the corresponding length OP is equal to PQ. It's because of corresponding size, congruent triangle. There are quite number of methods to prove it. Some of you may say that it's because of angle bisector here. So this angle equal to this angle, maybe you can use ASA or some other method to prove it. So we finished part A, which is the most difficult part. Even though you don't know how to finish part A, at least you must able to draw this figure. Without this figure, it's difficult for you to handle the rest. So part B, they try to put some coordinates now so that we can use slope or function of line, some equation of line to solve more precise results. They say that point O, this is origin, OO. Point Q, it is 40, 30. And then the y coordinate of P, x is unknown, but y is 19. Let C be the circle pass through OPQ. That means the circle is talking about the blue line here. And this circle is called C. So J is the center of C here. We have to find the equation of C. To get the equation of C, we need the coordinates of J. We also need the radius. To find out the position of J, we set up some strategy first. First, OQ perpendicular bisector is PJ. With our y coordinates, if we want, we can get x coordinate here. We have one line, we know that J fulfills this line requirement. Similar reason is not only one side, but also another side. If we draw a perpendicular bisector from OP, then it's passed through this line also. By simultaneous equation with the equation PJ and also this red line, then we can find out the position of point J. With the position of point J, we can find out the radius easily compared with origin. So that's our strategy. The first strategy is to find out the equation of PJ. Once we find out P, we can find out the midpoint and also the equation of this red line also. Then we can use simultaneous equation to find J. First stage, we have to get the perpendicular bisector of OQ. So point E is 2015 is the midpoint, and then slope OQ is equal to 3 over 4. That means slope PJ is equal to negative 4 over 3. So to write down equation of PJ, it is y minus 15 over x minus 20 is equal to negative 4 over 3. We get PJ already. Now we also want to know the x coordinate of P. So when y is equal to 19, 19 minus 15 over x minus 20 is equal to negative 4 over 3. This is 17. Then we can just repeat the similar thing in order to get the red line. We may let the midpoint denotes the midpoint of POP be F. And then F coordinate is 17 over 2, 19 over 2. Slope OP is equal to 19 over 17. Slope FJ is equal to negative 17 over 19. So, equation of FJ is equal to y minus 19 over 2 over x minus 17 over 2. So don't forget that we are going to compare the equation of PJ and the equation of FJ so that we can get the coordinate of J. For point J, y equal to negative 4 over 3x and then plus 1 to 5 over 3. Y at the same time is equal to this. By solving this, we know that x equal to 56 at the same time, y equal to negative 33. So we can find out the equation of C now. X minus 56 squared plus y minus 33, y plus 33 squared is equal to 4225 or 65 squared. That means the radius is 65. There are more methods. Maybe some of you will try to use J expressed in terms of one unknown only because it's lying on the black line, PJ. And then with the distance formula constraint, you can get the value of x or y after that. But some of the marking scheme, they give one method is let C, equation of C be x squared plus y squared plus dx plus ey plus f equal to 0. If you replace x, y pass through origin, if you replace both x, y by 0, you will find that f is also equal to 0. So it's be simplified to this formula. And then you may just substitute these 2 points and then you solve the simultaneous equation. You get the answer also. Why I use this method is just because this is the first method come up in my mind. And this method is useful even that the circle do not pass through the origin here. In part B2, they say that the circle, there are 2 tangents such that the slope is 3 over 4. Be aware that the slope of OQ is also 3 over 4. So what they say is there is 2 lines which is parallel to OQ and both tangent to the circle. And then these 2 lines will cut the x-axis and y-axis at certain point. So if we just focus on those 2 tangents, that means those 2 tangents may be like this. And then they say that the higher one is L1, the lower one is L2. And then L1 cut x-axis. This point is called point S. Y-axis point T. So we know that this point is point S, this point is point T. And then L2 cut x-axis at point U. Point U. And also y-axis at point V. What is asked is about the area of trapezium STUV. So we connect them. Talking about this area. exceeds certain amount. Is that claim correct? So we have to find out the area of this part. And then the best method is make good use of the rectangular coordinates. We always focus on horizontal line and vertical lines. So the method is to find out the position of S and U so that we can find out the base. We find out the position of T and V, we can find out the height. Then we can use the base of two triangles and also the corresponding height of two triangles to find out the area of this trapezium. That's our strategy. So now the first mission is find out the equation of these two straight lines by using tangent. Tangent, that means the intercept is number of solution is 1. That means the determinant equal to 0. We can log the value of the constant, that means y-intercept. Once we find out the y-intercept, we are going to find out x-intercept of these two lines. Then we can solve the problem. We let the tangent be y equal to 3 over 4x plus c. While we don't know what is the y-intercept, but we predicted that there will be two solutions to fulfill the requirement. We consider the intercept once again. So we are talking about x minus 56 squared plus y plus 33 squared equal to 4225. And y equal to 3 over 4x plus c. We put it inside and form a quadratic equation with x. So this is our quadratic equation with x squared, x term, constant term. Since it is a tangent, only one solution. Only one real root for x. Therefore, the delta is equal to 0. 3 over 2c minus 125 over 2 square minus 4 times 25 over 16 times c squared plus 66c is equal to 0. Both sides times 4. So if we draw this two lines, the first y-intercept is 25 over 4. That means point T is 25 over 4 here. And then point V, this is negative 625 over 4. Now we are concerning the position of S and U here. So L1 is y equal to 3 over 4x plus the higher one, 25 over 4. So at S, y equal to 0. X equal to negative 25 over 3. This position is negative 25 over 3. L2, y equal to 3 over 4x minus 625 over 4. At point U, y equal to 0. 3x. So x is equal to 625 over 3. Now to calculate the area, we get SU is equal to 625 over 3 and then plus 25 over 3. 650 over 3. Therefore, the area is equal to this triangle with height 25 over 4 plus this triangle with height 625 over 4. So it's 1 over 2. You get 105625 over 6. And this value is larger than 17,000, so we agree the claim. That's all for this question. So once again, the key point is whether you can draw properly, and then once we tell you about in-center, circumcenter, do you know their property? And then for perpendicular bisector of each length, you can find out the circle center, or just by the format of the circle equations, substitute some value, you may get the equation you need. And then just try to draw properly to understand what it's asking, because parts of the difficulties is because they don't provide you any graph. They are testing you whether you understand what is described. Even though you make any careless mistake, but in this question there are lots of method marks here. So for example, like if you know a tangent is one intercept only, if you consider the delta of the intercept is equal to 0, then you may get one method mark or even 2.